All right, so we're going to talk about section 5.6, proving that a quadrilateral is a parallelogram. So we've learned about all the properties of a parallelogram. You don't have to have all of those properties to know you for sure have a parallelogram. You're allowed to have like a set amount that will then allow you to conclude all the rest of it and therefore know that you definitely have a parallelogram. So let's dive right in. First way to know you have a parallelogram is if both pairs of opposite sides of a, we'll shorten it down here. If both pairs of opposite sides are parallel, that's one way. Okay, and then we're going to draw this as well. So once you got that typed up, go to your shapes tool, parallelogram, draw your little parallelogram, something like that. So if both pairs of opposite sides are parallel, top side and the bottom side are parallel, right side and the left side are parallel. So if you see this, it is definitely a parallelogram, and we would be able to conclude then all the properties of a parallelogram. So the top side and the bottom side would be congruent, the left side and the right side would be congruent, the opposite angles would be congruent, the diagonals would bisect each other. All the properties of a parallelogram would then be in play once you see this. Okay, questions on that? Number two, if both pairs of opposite sides are congruent. And same thing, go back to your parallelogram tool. Get your parallelogram going, something like that. So if the top side and the bottom side are congruent, and the right side and the left side are congruent, you know for sure this definitely has to be a parallelogram. Every other property of a parallelogram is now in play. Top side and bottom side are parallel, left and right side are parallel, opposite angles are congruent, the diagonals bisect each other, etc. Third way is if one pair of opposite sides is both congruent and parallel. So if one pair of opposite sides is both congruent and parallel, so let's draw a parallelogram, something like this. So let's say this top side and the bottom side is parallel. So one pair of opposite sides is both congruent and parallel, and the top side and the bottom side are also congruent. There you go. One pair of opposite sides is both congruent and parallel. This would definitely have to be a parallelogram. We would then know the left side and the right side are congruent, the left side and the right side are parallel, opposite angles are congruent, diagonals bisect each other, etc. Number four, if the diagonals bisect each other. So if the diagonals bisect each other, let's get some diagonals going here. Something like, I'm going to use my tool because I'm not great at freehanding the diagonals for some reason. Something like this. There, got it. And we'll do another one. something like that. Let me fix this one up a little bit. There we go. All right, so there's our diagonals. And we want them to bisect each other, so something like this is congruent to this, and that is congruent to that. So there you go. The diagonals are bisecting each other, so we know for sure this definitely has to be a parallelogram. It's the fourth way. So once you have something like this, you know the top and bottom side are congruent. They're also parallel. The left and the right side, they're congruent. They're also parallel. You know the opposite vertex angles are congruent also. And the fifth way to know that you have a parallelogram is if the opposite angles are congruent. So here we have our parallelogram.
Both pairs after?
Yeah, both pairs. So here is congruent to here, and here is congruent to here. So here's my advice. Much like the kite that we drew yesterday, all the properties of a kite, they're tough to memorize and regurgitate. But drawing the image of the kite with all the properties represented is much more manageable. Same thing here. You know, is it good to be able to regurgitate these? Sure. It's even better, I think, to be able to draw each of these. So ideally, you would like memorize these drawings, be able to recognize these drawings. You need to be able to like draw them if needed. You're probably not going to be asked to do that, but be prepared to just in case. Mostly it's an application of these. Questions on that? Okay. Those are the 5 ways of proving that a quadrilateral is a parallelogram. All right. So here is example 1. Try to use one of the 5 ways of proving a quadrilateral is a parallelogram to solve that proof. Okay. So I'm going to pause the video. If you're watching this now, pause the video to work on example 1. I'll come back with the solution to that. All right, so looking at this, we know that angle 1 is congruent to angle 2. These are alternate interior angles relative to the top side and the bottom side. So if alternate interior angles are congruent, then lines are parallel. FL has to be parallel to GA. Also, we're told that FGA has to be congruent to LAB right there. These are corresponding angles. I know the 3 angles are missing here, so they're not shown, but this would be in the top right, and LAB would also be in the top right. Those are corresponding angles, same position, different location. If corresponding angles are congruent, then lines are parallel, meaning FG is parallel to LA. So as we look at this parallelogram, opposite sides are parallel. So in the proof, it looks like this. 1 is congruent to 2, that's given. FL is therefore parallel to GA because if alternate interior angles are congruent, then lines are parallel. FGA is congruent to LAB, that's given. We're able to conclude from that FG is parallel to LA. If corresponding angles are congruent, then lines are parallel. And then finally, FLAG is a parallelogram because opposite sides are parallel. You could be a little bit wordier on number 5 here, that number 5 reason, but this is enough for me. It's everybody's favorite game to play at the holiday season. Grandma and granddad are in town, maybe aunts and uncles are in town. You're all sitting around, it's, you know, Friday night before Christmas. And, hey, what should we do? Let's play that game we used to play when we were kids. Is it a parallelogram or not? Okay, so go ahead, try it out. Is it a parallelogram or not? Or I should say, which one must be a parallelogram? Go ahead. This first one here. What do you think? Does it have to be a parallelogram?
Yeah.
It does. Why? Drew.
Because opposite sides are parallel because of the alternate interior
Okay, let's see.
angles. Because the top line is parallel to the
I wasn't thinking about that, but I think that would work. Let's see, 40 and 40. So those are alternate interior angles relative to the top and bottom. And then, yeah, 60 and 60, same thing. I would take that. That would be good. What's another reason? Like if you did something, Logan, what about you? Yeah, that's what I was thinking, right? So obviously we have a 100-degree angle here, a 100-degree angle here. 40 plus 60 is 100. Where does this angle have to be up here? 80. And then this one down here has to be 80 as well. So I would also take that. Either one of those would be good. Questions on that? Okay. Okay. And you can see like how things start to fall into place. You can also show these two triangles are congruent, right? You got the reflexive property in the middle. You've got angle side angles satisfied. Therefore, you could use CPCTC to show that the top and bottom are congruent, the left and right are congruent. And then you could say like both pairs of opposite sides are congruent. So like there's a number of ways that you could prove that this is a parallelogram. There's not just one that's correct. So yes on that one. How about this one? No. You might be thinking like, well, we have one pair of sides that are parallel, and we have one pair of sides that are congruent. But remember, if you go up to your reasons from up above, number 3 here, one pair of opposite sides is both congruent and parallel. Both congruent and parallel. So it needs to be the same side as congruent and parallel, not different sides. So no on that one. So yes on the first one we said, and no on that one. With that in mind, let's take a look at this one to the right. What do you think about that one? Oh, not that. Skirt. There. What do you think? Yes, right? That's exactly what we just talked about with number 3 up above. One pair of sides is both congruent and parallel. Let's take a look at the one above that. What do you think? Yes or no on that? All right, why?
Opposite sides are congruent.
Yeah, opposite sides are congruent. That one's yes. How about this one down here? What do you think, Nicholas?
I'm just blocking the sun.
Okay.
But yes,
All right, why?
because if opposite angles are congruent.
Yep, opposite angles are congruent. X and X, Y and Y, opposite angles are congruent. You can shut the blinds if you need to. And then on this one, what do you think? Yes or no? Yep, Violet, why? There you go. The diagonals bisect each other. That is definitely a parallelogram. All right. Feel free to take that home, share it with your family over the holiday break. Here we have a proof. I'm going to challenge you guys to try this one on your own. We have angle 3 and 4 are congruent. UG is congruent to GT. I would encourage you to kind of map it out in your head before you like really dive in. If you want to write down the given information, that's fine. But like before you start down a path, I would kind of map out a path in your head first and then try to execute it. Good luck. Our way through this. So we got angle 3 congruent to angle 4. What can we conclude from that if we wanted to? Raise your hand if you think you know. Jonathan.
PU
PU is
is parallel to TN.
parallel to TN, right? Because they're alternate interior angles. If alternate interior angles are congruent, then lines are parallel. We'll keep that in our back pocket. We may need it, we may not. What do you know about 5 and 6? They're vertical angles, so they have to be congruent. We're told the UG, we'll keep that in our back pocket as well, 5 and 6. We're told the UG is congruent to GT. That's the diagonal that's being bisected. There's only one of them. And we said a moment ago that 5 is congruent to 6. What do you notice? Alec?
You can say that triangle PUG is congruent to triangle NPG because of angle side angle.
That's right. Angle, side angle, these two triangles, PUG and NTG. Be careful with your congruency statements. These two triangles have to be congruent to each other. Now, to me, the easiest way from there to know that this is definitely a parallelogram, I would use CPCTC to show that NG is congruent to PG. That's going to be the way I go. But you could say, like I said earlier, PU is parallel to NT, and then CPCTC with those two triangles, PU is congruent to TN. One pair of sides is both congruent and parallel. That would also work. So if you went that way, that's okay. You could also say, let me think here. Let's see here. You would need to know these two are congruent to know that the left and right side are parallel, and we can't easily prove that. And same thing here. You would have to prove these two are congruent to know that the left and right side are parallel as well. So that's not easily proven either. So that's probably a bad way to go. Is there anything I'm not thinking about from people in class? Is there something you did that I'm not talking about, Jonathan?
Could you say that PT and UN are parallel?
PT and UN. I don't think there's a way to prove easily that PT and UN are parallel. I think you first have to prove that PU is parallel to NT, and then PU is congruent to NT, or you could show the diagonals are bisected, either way. And then once you have a parallelogram, then yes, PT would have to be parallel to UN. So here we go. I'm going to use the diagonals being bisected. Number 1, angle 3 is congruent to angle 4. Oh, given. From this, I'm able to conclude that hang on. I actually don't need that. Okay. We'll say next UG is congruent to GT. That was given. So that's one diagonal that's being bisected. Number 3, angle 5 is congruent to angle 6. Vertical angles are congruent. Number 4, triangle PUG. Be careful with your congruency statement, is equal to, or congruent to, triangle. All right, P, that's a blank angle. N is a blank angle. U came second. That is the one tick mark angle. So T has to come second, and then G and G. That's ASA. Number 5, I'm going to say that PG, right, that's right here, is congruent to NG. That's right here. So that's my second diagonal that's been bisected. CPCTC. And now number 6, PUNT is a parallelogram. Both diagonals are bisected. Something like that. That's not the only way to word it, but something like that. There you go. I think that's the end, right? All right, very good. Thanks for watching. Good luck on the homework, everybody. Take care. Quiz next class. Quiz next class. This is not on it. 5.6 is not on it. Everything up to 5.6.